Hi all, now we are going to see about Prim's and Kruskal algorithm in multi-way search tree and graphs topic. So Prim's and Kruskal algorithms comes under minimum spanning tree topic. So what is minimum spanning tree is, so in a graph with vertices and edges, we have to visit all the vertex only once, and but the edges can be neglected without forming a cyclic pattern. So this is the ultimate aim of the minimum spanning tree. So all the vertices must be visited, but the edges can be neglected, but cycle should not be formed. So this is what minimum spanning tree is. So in minimum spanning tree we'll be having two algorithms, namely Prim's and Kruskal algorithm. So Prim's and Kruskal algorithm is explained in detail in the video. So let's move on to the video. So before going into the Prim's and Kruskal algorithm, let's have a small recall about what the terminologies and graphs are. So a connected graph. So what is connected graph is a graph where every vertex is reachable from every other vertex. So those type of graphs are called connected graphs. In graphs we have strongly connected graphs and weakly connected graphs also. So the next one is undirected graph. So the graph with edges that have no directions and no weights are called undirected graph. So then the third one is spanning tree. The tree that connects all the vertices of graph with minimum cost is called spanning tree. So the next one is edge weight. So the numerical value assigned to each edge in a graph, that is to reach a vertex from one vertex to another vertex. What is the cost of reaching from one vertex to another vertex is called edge weight. So these are all the terminologies we have to recall before going into the Prim's and Kruskal algorithm. So the empathy. So then empathy is to visit all the nodes. So here the nodes are these are called nodes. So the empathy is to visit all the nodes from the source node and with the minimum cost. So this is the empathy of this algorithm. So Prim's algorithm. So here we have two algorithms. One is Prim's algorithm and the other one is Kruskal's algorithm. So in Prim's algorithm, what we'll be doing is we are going to first initialize the variables, process the input data, then we are going to execute the core logic, generate the output, format output and release resources. So these are all the algorithm which are followed in Prim's algorithm. So in Prim's, what we have to do is first consider this given graph. So in this given graph we have to first identify the source node, that is from which node we are going to start our algorithm. So here now I am fixing the starting node as B. So in step 1 C, so the B node is the starting node. So from B node we have to find the adjacent nodes of B. So the adjacent nodes of B are D and C with the weight. So B to C 10 and B to D 10. So the adjacent nodes of B are D and C with weights 4 and 10. So the minimum among these two is B to D 4. So the B to D 4 is alone retained. So remaining retains as dotted lines. So the dotted line B to 4 is alone considered retained, and then B to C with weight 10 is retained with dotted line alone. So here check the difference. B to D is a continuous line and B to C which is a dotted line. So in step 3, next we are going to consider the adjacent nodes of D. So B to D is confirmed now. So B to C is not yet confirmed. It is with dotted lines but it is retained. So B to D is confirmed with weight 4 and we are going to visit the adjacent nodes of this new added vertex D. So after B, the node added to the list is D. So the adjacent nodes of D's are considered into the play. So the adjacent nodes of D are C and then E with weights 2 and 1. So this is added into the step 3 with dotted lines. So among these three, so D to E is 1, D to C is 2 and B to C is 10. So among these three, which is least is D to E with edge weight 1. So this is confirmed and the remaining two will be in the retaining list. So 4 to 1, B to D4 is confirmed. Next D to E1 is confirmed. In the next step we'll be confirming D to C 2 with weight 2 is confirmed. So next the adjacent nodes of the upcoming nodes will be added into the steps, and finally we'll get this output. So B to D4, D to E1, D to C2, and then C to A3. So this is the final minimum spanning tree of the given graph. So in Prim's Kruskal algorithm, we'll be exploring from the node and we'll be visiting the adjacent nodes of the recently added node. So this is the algorithm which Prim's follows. So here consider this output. So each and every vertex given in the graph will be visited, but some edges will be neglected. So ultimate aim of Prim's algorithm is to visit all the vertices, but edges can be neglected. So next is Kruskal's algorithm. So here what we have to do is we have to sort the given edges in the ascending order, then we'll be adding edges into the graph, output graph, one by one based on the ascending order. If the edge forms the cycle, we'll remove the edge and we'll be adding the next edge into the output. So let's see how this algorithm works. So consider this graph. So this graph is having 9 nodes with from A to I. So first we have to sort the edges. So first we'll be adding the edges with weight 1 into the output graph. So this is the given graph, this is the output graph. So the edges with weight 1 is first added into the output graph, that is B to D1. So here it is added. So next G to H is 1, so that is added. So the no other edges with weight 1 is there. So we'll go to the next edge weight, so 2. So here 2, B to C 2 is added. So the next I to H2 is also added. So the next E to D2 is also added into the output graph. Okay, so next one, so the weight is 3. So edge weight 2 is over. Now we're going to concentrate on edge weight 3. So edge weight 3, E to G 3 is added, G to I 3 is not added into the output graph since it forms a cycle. So when we add 3 into this output graph, it forms a cycle. So the 3 is not added into the output graph. So likewise, so from ascending order of the edges will be adding into the output graph. Suppose the edge adding into the output forms a cycle, we'll be neglecting that edge and will be continuing with the next edge. So this is the process which Kruskal algorithm follows, but the output of the Prim's algorithm and Kruskal algorithm will be the same. So here also note that all the vertices are visited, but the edges can be neglected. So as I said in Prim's algorithm, all the vertices must be visited. Here also all the vertices must be visited and some edges can be neglected since it will be forming a cycle. So this is another example of Kruskal algorithm.